going to start a little bit more about graphing, and this is section 3.2. In particular, we're talking about how we find the slope of a line. The slope is the slant and the direction that a line takes. It can easily be determined on a graph by counting spaces between two fixed points. Okay, the slope is the ratio of the vertical change to the horizontal change. Okay, so we call that the rise over the run, and we're going to see that a couple times and we talk about it. So if you're asked to find the slope of a line between 2 points, you can easily just count spaces. So if the rise is up and down, how far we go vertically, so up and down, then start at a point and see how far you have to go up before you can move over to get to the next dot. So in this case, this would be 1 space up, and this would be 2 spaces over. So 2 going this way, 1 going that way. So my slope here would be rise, which would be going up 1, and run, we're going 2, and we're going to the right, so those would both be positive numbers. And notice, if the line is leaning over to the right, the slope number is going to be positive. So now watch what happens on this one. If I start at this point, okay, I'm going to count up from this point and go 1, 2, 3, 4. Oops, I lost my space. 1, 2, 3, 4, 5. So I'm going up 5 spaces, and then I'm going to go over 4 spaces. So up 5, but 4 goes to the left. So my 5 would be a positive number and my 4 would be a negative number. Now, what if I went the other way? What if I started up here and tried to come down to get to this point? Well, it's really not going to change, because here's what happened. We go this way, I'm going to go down 5, and then I'm going to go 4 in the positive direction. So in any case, I go 1 negative direction. So it could be positive 5 and a negative on the 4, or the negative on the 5 and the positive on the 4. In either case, we're still going to get the same amount and the same numbers that we have right here. So when we have a negative slope, the line is going to lean to the left. And one of these numbers has to be negative. Now, the thing is, here we could do the same thing, but if I'm going to go from the right-hand point to get to this left-hand point, I would go down 1, so this would be 1, but it's going to be negative 1, and then I would go 2 to the left, which would be negative 2. So this one would have negative numbers on both spots. But then what's negative divided by negative? That'd be a positive 1/2. So your slope can be measured by any direction of the points that you do. I can go up and to the right from the lowest point up here to the highest, or I could reverse it, but I'm still going to end up with the same slope numbers, just some sign changes in it. Okay, now let's look at this one. This one is a little bit more unique, because if I look at this point, I'm not going to go up or down anywhere. So my rise is 0, but my run, I'm going over 1 space. So I'd be 0 over 1, which says 0 divided by anything is just going to come out to be a whole number of 0. So here's the uniqueness. Notice this. It slants to the right if the slope is positive, and negative over negative makes a positive number. If it goes to the left, one of these will have a negative number on it. And if it goes across horizontally, it's going to have a 0 on the top. We're going to learn a little bit more about horizontal and vertical lines in just a minute. But this is an easy way to find slope. So if you have a graph, it's real easy. You just count spaces. Count how far up, how far over. How far down, how far over. You can use either direction. But when they just give you 2 points and they don't have a picture of it, we're going to use a slope formula. So put a star on this one on your notes, because you have to know this formula. So if you're just given 2 points, this should be an x1. Oh, that's right. This is a 2. I didn't need So here's your formula. Now what this means is you're going to have two x values and you're going to have two y values. So if our top number is always how far we go up or down, the y-axis is where we go up or down. So the y values always go on top and the x values go on bottom. Now we have to find the difference between those two values. So we're going to take our y value, and it does not matter which one you designate as x2, y2, and x1, y1. The slope, like we demonstrated right here, is going to be the same whichever direction you go. Now, slope is designated with a lowercase m, so that's why it says m equals. This is your formula. This whole thing is your formula. So when you write slope, you write m equals, and then you fill in the numbers. Okay, the vertical change, like I said, is the rise, and the horizontal change is the run, so we'll see it written as rise over 1. Now, a slope number must be expressed as a fraction in order to be used for graphing, and it has to be a single fraction, so it can't have a whole number with it. So I could have 4 over 3, I could have negative 5 over 2, I could have 2 over 3, I could have a whole number, 5, because that I can write as a fraction, then it would be up 5 and over 1. So these are examples, but they cannot be a mixed numeral, okay? So if I'm thinking 2 and 1/8, no, that won't work, okay? I have to have it as a single fraction to be able to count rise over run. Alright, now it says find the slope between these 2 points. Now certainly you could go and put them on a graph and count the spaces just like we did up here, but now we're going to use our formula. So the formula, notice, has a minus in the middle of it. So whatever these numbers are, if there's a negative sign and there's one right there, I'm still going to stick a negative sign on that number. So I'm going to go and I'm going to find me a y value. It does not matter which y value you use. So I'm just going to look at this first one and call that y2 and call it 6. So that's 6 minus, that's the formula, and my next y value is negative 6. So I'm going to put that in parentheses since I've got so many negative signs. Okay, now whichever y value you put on the top in the front, its x value has to go underneath it. So the positive 6 went first on y, so the 8 goes first on the bottom. Then I put the minus sign from the formula and go over here and find positive 6 as my number. So be careful when you've got that minus sign and another number. So now this changes to a positive, and I'll end up with 12 on top. And 8 minus 6 will be 2. 12 can divide evenly by 2, so I come out with the number 6. And I can write it as 6 over 1 if that helps me feel better, because I know it would go up 6 and over 1. In a minute we'll talk about what these transitions would do to a line and how it affects the line. So you would know some things by just looking at the slope number. Already up here we already figured it out. If the slope number is positive, it's going to slant to the right. If the slope number is negative, it's going to slant to the left. If the slope comes out to be a 0 on top, which is just equal to 0, it will be horizontal. So we've got some things to work out with. Alright, find the slope of the line that contains the point 7/2, 2, minus, and negative 3, 0. Alright, so I'm going to put in a y value. It doesn't matter which one. Just for the sake of having a number, instead of 0, I'm going to put the 2 first. So I'm going to say 2 minus 0, and then on the bottom I'll put 7/2 minus negative 3. So that's plus 3. That's going to end up being plus 3. But what is this number? If it works better for you, that would be fine to put that number as 3.5. Okay, 2 goes into 7 3 times with 1 left over. So you can make that be 2 over 3.5 plus 3, because this will come back to be a plus. Then I have 2 divided by 6.5. Now the problem is I can't get an answer of 6.5 here. I need this to be whole numbers. So I need to figure out how am I going to get this to be a whole number. Well, if I multiply the top by 10 and the bottom by 10, it's going to move that decimal value over. So the best thing for me to do is to multiply the bottom by 10. That'll shift that decimal place. But whatever I do on the bottom, I have to do on the top. So I'm going to have to multiply that by 10. Moving a decimal place is the same as multiplying by 10. So now I've got 20 over 65, and I don't have any more decimals. And then I can just divide. So these will both divide by 5. 20 divided by 5 would come out to be 4, and 65 divided by 5 would be 13. So my slope value here is 4 over 13. Okay, look at this next one. And again, it's got some decimal values in it. So we're going to have to use that concept there. That's the easiest way to do it. Multiply by that decimal by the place value here. We have one place value, so that would be times a power of 10. Alright, so here we're going to do the same thing. I'm going to put my y's on the top. I'm going to take the biggest number, so this time I'm going to go here and take this y value 4 minus the other y value of 3. Doesn't matter which one you choose to put first, but whatever partner goes underneath. So 4, 4, the 4 has to go under, minus 4.5. So subtract them, I'll get 1 on the top, and 4.0 minus 4.5 is going to be negative 0.5, or negative 0.5. I don't want a decimal down here, so my power is one decimal place. So if I multiply by 10, it's going to move it over, and then multiply by 10 here. Okay? One decimal place. So now I have 10 on the top, and I'm going to have negative 5 on the bottom. Then simplify it. 10 divided by negative 5 would be negative 2. And you can leave it as a whole number, negative 2, or you can put it negative 2 over 1. If you're going to use it on the graph, then having it in a fraction form is fine. But if they just ask you for a slope number, then you can just put it as negative 2, a whole number. Up here, you could just put it as positive 6, a whole number, but here it has to be a fraction. Okay, so you have to be able to use that slope formula, and you can't be afraid of using it with fractions or with decimals. So if you've got a decimal in the bottom of it, you can't leave it that way. What you're going to do is multiply by the power of 10. That'll move it over to get to the back of the number. So we got it to the back by multiplying by 10, then multiply by the same thing on the top. Now, there's two special cases, kind of like what we talked about up here with this 0 ending up on top. So this means it doesn't go up or down any, but it goes across. So we call that the slope here of a horizontal line then would end up being 0. Well, we also have one called undefined slope. Okay, a value is considered undefined when the denominator of a fraction comes out to be 0. Not the numerator, but the denominator. Okay, if the denominator has a 0, then it's undefined. So when the slope numbers combine to get a 0 for the run, the answer is undefined. Not 0, but you write the word undefined. Okay? So that means the denominator comes out to be a 0. Now, these are really easy problems. So look and see. In order to get a 0, two numbers have to be exactly the same because we're going to subtract them. So if I have 8 as my y value and a minus, and then I have negative 2, then on the bottom I have a 4 minus 4. So this comes out to be 10 on the top but 0 on the bottom. So here basically, if the x values are the same number, then the slope is going to be written as undefined. Okay? And the graph is going to be a vertical line on the graph. You could plot those 2 points, but you would be able to see that the line is going to go up and down. It'll be a vertical line that looks something like that. So now here, when you write your answer, that's not your answer. The word that you write is undefined. Okay? Sometimes you see it written as no slope. Doesn't lean either way. So undefined or no slope isn't acceptable. These are easy problems to figure out. So when you get a problem to work on, before you ever get started, look and see if your two x values are the same. If the two x values are the same, you don't even have to do this. You just write undefined. Now they have to be the exact same number and the exact same sign. Okay, so here, if this gives us a vertical line, and we saw up here at the top that the 0 on top gives us a horizontal line, let's look and see how that happens. Okay, here I got another example. So I've got a 1/2 and a 1/2. Now I would kind of get freaked out if I looked at this and thought, oh no, I have to put those in the slope formula. Well, look carefully. 1/2 on the x and 1/2 on the x means my x's are going to work together to be a 0. Okay, my x's are going to give me a 0. So that would mean I'd have a 0 on the bottom. It doesn't even matter what's on the top. So it's going to just be some number on the top, but 0 shows up on the bottom. Then all you have to do is write undefined. You don't even have to work it. Just undefined. Okay, check the problem before you get started and trying to cram it into the formula. Look at the numbers and see. You might not even have to do anything. Okay, so now the reverse of that is when the answer comes out to be 0, that means there's a 0 in the numerator of the fraction. Well, a 0 being in the numerator of the fraction means that the y values had to be the same. So 0 on the numerator here, I'd have 3 minus 3, and on the bottom, a -7 minus 6. That's going to give me a 0 on the top and a -13 on the bottom. It doesn't matter what's on the bottom here, because the thing that rules here is the 0. So if the 0's on top, your answer is 0. That's what you write. So here, if the 0's on the bottom, you write undefined. If the 0's on the top, you write 0. So it looks like a bullseye if I do that. Now, basically, see if the y values are the same. Before you even start working on the problem, look at the numbers. If they are, the slope is 0, and the graph will be a horizontal line if we put it on the graph. Okay, so here, if I look at this problem and I'm scared of fractions, I would think, oh no, I don't want to do this. Well, look at the numbers. If the y values are the same, they're going to subtract off. That'll be 0. So here my answer would just be 0 on top and some number on the bottom. Then my answer is 0. So that makes it easy. But look at the numbers first. Now, here's the basics. This is a test question. Okay? It's going to probably be written just like this, and you'll have to fill it in. If the slope is undefined, then the line is vertical. If the slope is m equals 0, if the slope is 0, the line is horizontal. If the slope is negative, the line leans left. The slope is positive, the line leans right. Okay? So put a star on that, make sure you understand that, because slope and the shape of that line are both very important. Now, slope-intercept form is a way that an equation could be when we work with this. And on the previous notes, we had to graph some lines, and we talked a little bit about this, but now here's a really special thing that can be. you're going to have to find the slope. So if we look, we know that slope has an m. So if we look in this equation, it has an m in it. And so you can identify the slope by looking at the m. So if I can get my equation to look like this, where I have a y by itself and then everything else on the other side, then whatever that number is next to the x is going to be your slope value. So here, my slope is a 3 because it's the number next to the x. What's the number in front of this x? This would be a -1. So my slope here is -1. Over here, my 5/3 would be my slope. Now here, there's not an x. So what had to be multiplied by the x in order for it to disappear? Well, then this problem would have started out looking like this. Because 0 times anything would just be 0, so that would fall off and it just leaves y equals -2. So what's the number next to x? So m is 0. Now, if you just have a y equals line, it's going to flip the other way. So that other slope value that went with the zero, that only was affected by zeros, would be the other version of it. So x equals 0, x equals a number would be flipped the other way. Now, there's one other concept that we have to talk about here, and that is the relationships between slopes of parallel lines and the slopes of perpendicular lines. Lines that are parallel are going to have the same slope values. That means that they would start at one point, but they would rise and run at the same units all the way across. And so they would never cross and never touch each other. Lines that are perpendicular have slopes that are, the values are negative reciprocals of each other. Now, when an equation is in standard form, so that it looks like this, where the a and b are going to be whole numbers, x and y are variables, and c is a number, you have to solve the equation for y in order to put it in slope-intercept form. And then you find that number that's next to the x in the same position of m, and you found your slope. So we have to be able to solve an equation if we're going to try to identify slope. Now, we solve an equation that we're trying to get a value for y in the same way that we would solve an equation that we would just be trying to find a value for x. So if I want the y term to be left by itself, I need to get this 3x to move out of the way. And the only way I move things is to do the opposite. So what I would have to do here is subtract 3x and subtract 3x. Now remember, the form that we're looking for is y equals mx plus b. So when I move this over, I want to put this x term so that it's in the same position that this is. So I would have negative 2y equals negative 3x plus 7. Okay? Then you're going to divide each term, this time by -2. And it asks me for the slope. So for slope, I'm going to come back here and I'm going to look for this number next to x, which is right there. Now, it's negative divided by negative, which is going to come out to be a positive number, so my slope is 3/2. Now, parallel lines, flip back on the other page, it says parallel lines have the same slope. Okay, parallel lines have the same slope. So I want to know what the parallel slope is going to be for this problem. Well, it has to be the same as this. It would have to be 3/2. Now, perpendicular slope, it says they have to be negative reciprocals. Well, that just means they have to have opposite signs, but then you're going to flip your numerator and your denominator. So if I want the perpendicular slope for this one is positive, so my new answer has to be negative, and then I'm just going to swap places, so it would be negative 2/3. So first you want to change the equation around and get it into y equals mx plus b. So this will be a y, and here's your m, your x, and here's your b. But we're not concerned about anything but m in this problem. So on this problem, I'm going to do kind of the same thing. This 5x needs to move over. So I'm going to have 6y equals negative 5x plus 42. When it subtracts, it goes to the other side and you're going to subtract it. So now divide by 6. And I got y equals negative 5/6x plus 7. So now I'm looking for the number next to x. So here's that slope number, negative 5/6. So my slope is negative 5/6. My parallel slope will be negative 5/6. And my perpendicular slope, I'm going to get the opposite sign, so this new one will be positive, and flip the numbers will be 6/5. So there's the information. We need to know perpendicular and we need to know parallel lines. Okay, this last one, I need to get the y by itself. So this 7x is going to move over here and I'm going to subtract it. Then I get negative 6y equals negative 7x minus 18. I'm going to divide each term by negative 6. And I get y equals 7/6x plus 3. So my slope number is right here. It'd be 7/6. My parallel slope will be the same number. My perpendicular is going to change the sign, so it'll become negative. And then I'm going to get the reciprocal, which would be 6/7. So the big problem here is getting everything moved so that the numbers are correct. Now, if you make mistakes in this moving process, then none of this work will ever be right. So you have to be really confident in moving equations around to get what you're trying to find. Remember, when an expression or a term moves to the other side of the equal sign, it has to change its sign. And we want to put this in the form that matches here. So we want that whatever we move that has an X on it, we want it to fall right after the equal sign. So you'll have a little bit of information like that on your homework assignment. Now, one of the problems asks you to determine what's happening with these. So what you need to do is use your slope formula, and we're going to find the slope for the first line. So I'm going to write m, but I'm going to write a little k beside it. So I'm going to find the slope of line k. I'm going to use my formula. So I'm going to take the 7 minus the negative 5, and then I'm going to take the 1 minus negative 3. So this will become plus, and I get 12/4. So the slope number for the top for line K is 3. Now, if I want them to be parallel, the next slope would have to be 3. If I want them to be perpendicular, if I think of this as being 3/1, perpendicular is going to switch to a negative and it's going to flip it and be 1/3. So I need to do the other one and see what it comes out to be. So I'm going to do the slope for line N, and that will be negative 9 minus 3. I'm going to just use this number first. So if I put negative 9 first, I have to put negative 2 first. Then I have a negative 9 and a negative 3 would be negative 12. And negative 2 would be negative 4. Negative divided by negative is going to give me a positive, and it will also come out to be 3. So your question says, are they parallel? That means they have to have the same slope. And yes, they do have the same slope. So your answer here is yes, they are parallel. Okay, once you get one of them right, then you don't have to do anything else. So that works. Now, knowing an equation is in y equals mx plus b form, or what we call slope-intercept form, helps us have two really special parts. They're important pieces of information. We've already considered that the m has to be the slope. Okay, the b is going to be our y-intercept. Okay, it's going to be a number that's going to be located on the y-axis. So you can simply plot and graph this line. You can basically graph any line by putting it in this form, and it makes it super easy compared to what we did in the other unit in 3.1. So here, if we got it all right, and when we swapped it around, if we had to, we're going to find the m and the b, and then we're going to put it on a graph. Well, my lines didn't quite line up here. I think I even lost one of the numbers, but we're missing a graph right there. We'll just do b. Okay, y equals 3x plus 2. So the 3 is next to x, so my slope is going to be 3 over 1. Okay, we're going to put that one right here. My slope is 3 over 1. Alright, my b value is this number back here, but it's an ordered pair. So it means it's a y-intercept, so that has a 0 for the x spot and a number for the y spot. So my y-intercept is 0, 2. Now, I'm going to plot it on a graph and see if we can't get this one graphed pretty easily. Let me draw my grid right here. Okay, over here, I'm going to go ahead and do this one the same way. So now, on this line, this is the B one, I'm going to plot 0, 2. So whatever you'd have here in the B number, it's going to be along the y-axis. So 0, 2, x is 0, y is 2 is going to be right there. Then from that dot, that's your starting point. Then you count your slope and do what the slope says to do. So that says go 3 in the positive direction, that's going up 3, so 1, 2, 3. 1 in a positive direction is going to the right, so there's 3, up 3 over 1. Now it's easier to get your line to look better on paper if you have more than 2 dots. So if I go back to this spot, remember if I reverse this and make it as negative on both numbers, the results are the same. So all I have to do is transfer the pattern down so that I get the third dot to line up too. And then there's my dots, and there's what forms my line. Now, when you draw a graph that has a number line on it, especially in this situation, you would have to have the equation on the line. So I'm going to go back here and write y equals 3x plus 2. In class, we'll have another one right there. Since I didn't catch this before I started, I lost that one off. Okay, so let's go over here. This is C here, and D will be right there. All right, so look at the numbers. We've got the number next to x, so that's negative 4/3, and the b value is 0, negative 1. Now on a test or information that you have, if it asks for an intercept, it has to be in ordered pair form. Alright, so my starting place is what my b number is. Okay, start here. So I'm going to go 0, negative 1, which would be down here. Then my slope says go down 4 and 3 to the right. So 1, 2, 3, 4, 1, 2, 3. Now remember, when we first started this, we said, or reverse it. Let the 4 be positive and let the 3 be negative. If I go back to my original starting place and count 1, 2, 3, 4, 1, 2, 3, now if I draw the line, they're still lined up together. So really, the best thing to do is to have 3 points by counting your slope each direction. So count it once with the way that you find the answer, count it the other way, going the other direction. So that would be y equals negative 4/3 x minus 1. Now D, we're going to put this other graph on the same spot, on the same grid. I'll put it with a different color. Okay, so the green one, we're going to make this one green. So this one, the m number is the number next to x. So my m is negative 4, and we'll just, for the sake of needing it to be a fraction, we'll put it as negative 4/1. It's going to start at 0, 3. So I'm going to go up 3, 1, 2, 3. There's my intercept. That's this number. And then I'm going to do what this slope says. So I'm going to go down 4, 1, 2, 3, 4 over 1. Now, I've got enough room to go ahead and keep counting that direction, so I can do that. 1, 2, 3, 4 over 1. Then line up your dots and draw your line. After you draw your line, write your equation on it. So this equation is going to be y equals negative 4x plus 3. Okay? We didn't have one over here, so I'll go back and have an extra one when we're in class. Now, this is the easiest way to graph, but if your math skills are difficult and having a hard time with that, you're going to have a hard time getting it into this slope-intercept form where you got all the numbers and the signs right. So you have to be really careful. If this is not already in slope-intercept form, you might have to move it around in order to get that to happen. So this will give you a good little head start on graphing for the material that's in